In the tutorial, Tube Bells Improvement Part 1, we made simple changes to envelopes for giving sharp attack. For this tutorial, applying the algorithm interchangeability, we will aim to create another Tube Bells patch with sharp attack. We will use the original Tube Bells patch so that we can clearly hear the impact of changes that we've made with algorithm interchangeability. So, where do we start? We will start from algorithm, then work through other priority parameters. So, what we've learned about algorithm interchangeability. Remember from the tutorial, Algorithm Beyond Groups? I talked about the stacking and the branching combination group 3. They include algorithm 5, 6, 7, 8, 9, 12, and 13. They have a common structure as the basic positions and the modulation of operators 1, 2, 3, and 4 remain the same, but the position and the roles of operators 5 and 6 are different. We want to create a sharp attack sound. This usually involves in introducing additional harmonics and inharmonics. So, what do we need? Like the original Tube Bells, we need 2 towers for bell inharmonic chorusing. Then, we need 1 operator for a hammer tone and another operator for additional sharp attack tone. As you will notice, this is still the divide and conquer approach. Basically, you assign each operator to create specific harmonics and inharmonics. We will look at algorithms 7, 8, and 9. They all have 3 operators stacking with operators 3, 5, and 6. When you have a tower with 3 operators stacking, you can create higher harmonic modulation. For this exercise, as we are not necessarily looking at producing such high harmonic tones, we can eliminate using algorithm 7, 8, and 9. Now, we will look into the other algorithms, 12 and 13. They all have 2 operators stacking as maximum. Operators 5 and 6 are both modulators and directly linked to operator 3, which is a carrier. So based on our understanding, how do we decide which one to use? Compare algorithm 5 against algorithms 12 and 13. Tower 1 with operators 1 and 2 remains the same. Tower 2 with operators 3 and 4 remain the same, but operators 5 and 6 are different. My choice of algorithm for this exercise is 13. Use operators 5 and 6 as modulators that are directly linked to operator 3. We will use operator 5 for a hammer tone. We will use operator 6 for attack with additional harmonics using its feedback loop. Let's get our hands dirty. We can change algorithm by going to algorithm screen. Press the edit button and press button 7. You can use the slider or data entry button to select algorithm 13. After completed, when you press a key, it has too much modulation, as operators 5 and 6 output levels are set at 99 and 85 respectively. So what happened? We basically increased the number of modulators. Now it's 4 instead of 3 modulators and 3 carriers with algorithm 5. This means that you have more flexibility in FM sound design. Now, what we want to do is to create a sharper attack tone, so we will focus on operators 5 and 6 for editing. You can turn on operators 5 and 6 only by using operator on and off buttons. And don't forget to turn on operator 3, as it is a carrier for operators 5 and 6. Otherwise, you don't hear any sound. Press button A to see the feedback level. At the moment, it's at maximum of 7. We can leave it as is. Now, we will look into frequency. Press button 19 and use operator select button to select operator 5. You can turn off operator 6, but make sure to keep operator 3 on. As you recall, operator 5 uses fixed frequency at 323.6 Hz, producing a hammer-like tone for additional inharmonic tone. As a general rule, fixed frequency around 100 to 200 Hz emulates a hammer tone better. At over 300 Hz, there is too much inharmonic tones, so we will change that to around 150 Hz. Press button 19 and adjust frequency to 158.5 Hz. Now, we can work on operator 6 by turning off operator 5 and put operator 6 on. Press button 18 and use operator select to select operator 6. We can adjust the ratio by going up from 2.0. Note that you may not be able to hear the modulation of operator 6 clearly. It seems that it has very short decay. We can go to envelope generator to check both operators 5 and 6. Press buttons 21 and 22 and use operator select button to see how envelopes are set for each operator. Make sure to turn on operator 5 as well. For operator 5, we will change rate 1 as it is slower than that of operator 6. Because we want to emulate a hammer tone, we will have faster attack by increasing rate 1 to 98. Now, we will look at operator 6. Rate 2 has fast decay as it is 91. This is just too fast for producing a metallic attack, so we will reduce rate 2 by about 10 increments. So try 80, 70, 60, 50, 40, 30, etc. Let's listen to these changes. We also want to retain the original tube bells tonal characteristics. Based on these changes, we will set rate 2 to 60, which is an optimum level between having sharp attack and retaining the original tonal characteristics. So, once we've got the envelope right, we will go back to operator 6 ratio. Now, you can turn on operators 4 and 5 so you can hear how operator 6 modulation affect overall tube bells sound. Remember that your goal is to find a ratio that gives you the sharpest attack tone. The easiest way to find the sweet spot is to use a multiple of the underlying ratio that you want to improve. In this example, we have a ratio of 3.50 with operator 4 to generate better inharmonics. So, you can try a ratio of 7.00. If you set operator 6 with other ratios, you will notice it produces additional harmonics and makes the overall sound too harmonic rich, and it basically loses sharper, better inharmonic tones. We can summarize what we've done so far. We changed the algorithm from 5 to 13. We changed operators 5 fixed frequency from 323.6 Hz to 158.5 Hz. We changed operator 5 rate 1 from 76 to 98. We changed operator 6 rate 2 from 91 to 60. We changed operator 6 frequency ratio from 2.00 to 7.00. So what else do we need to do? We know that operators 5 and 6 are producing too much modulation. What is the next step? We will adjust the output levels of operators 5 and 6. Press button 27 and use operator select to go to operator 5. Turn off operators 4 and 6 to hear the output of operators 5 only, and make sure to have operator 3 on. At the moment, operator 5 output level is 99. We can lower it by about 10 increments to see what will happen. We can comfortably set between 80 to 90 for hammer type inharmonics. Let's set it to 90. Now, we will change operator 6. Turn off operator 5 and turn on operator 6. Press operator select to go to operator 6. Operator 6 output level is 85. If you are introducing a metallic tone, if you set output level high, 70 or more, then you will produce too much modulation. The sound gets distorted and it loses its sharpness. We will reduce output level by about 10 increments and carefully listen to how it affects the sound. Let's listen to the sound from 85, 75, and 65. At 65, its modulation is significantly reduced. As we have an underlying metallic tone from operator 4 at 3.50, we will keep it as 65. Now, we created another tube bells patch with a hammer tone. Turn on operators 4 and 5 and listen to how attack is now sharper and solid. We can also turn on operators 1 and 2 and listen to the overall sound. Let's compare the original and the new hammer tube bells. So by just applying the algorithm interchangeability, you can make a sound with a sharp and solid attack. So we've achieved a lot in this short tutorial. Let's revise what we've done so far. By changing algorithm using the algorithm interchangeability, we created an additional modulator which gave us more flexibility in FM sound design. We changed the fixed frequency and the frequency ratio to generate a hammer tone and sharper attack. We changed the envelope decay to get a right balance between sharp attack and additional harmonics. We changed the output level to get the right balance of modulation from each modulator. You can pause here to do self-learning tutorial. You can think about what else you can do to make further improvements, especially focusing on priority parameters. You can try changing a few priority parameters and learn how these changes affect the overall tone. You can also think about whether changing low priority parameters will make a big difference in the overall tone. You can try changing a few low priority parameters and learn how those changes affect the overall tone. For the next tutorial, we will look into the sound design tube bells improvement part 3.